I'm going to save you a bunch of time and frustration. Please screenshot these settings so you always have them. What is up, y'alls? If you are new to 3D printing or just looking for some helpful tips and tricks, I'm going to be covering the top 5 tips that I wish I would have known before diving into 3D printing myself that would have saved me a ton of time and headaches. Hopefully, some of this info helps you avoid some frustration and mistakes that I made when I was first starting out. So, let's get into it. Tip number 1 is going to be figuring out what your goals and intentions are for 3D printing. Now, I know that sounds a little existential and deep, but hear me out. It really helps you narrow down what type, brand, model, and features you're going to be looking for in your first 3D printer, especially since the market has become pretty saturated with tons of different printer options now. If I had considered some of this info when I first started, I actually would have got a completely different printer than the first one I bought. Would have saved me tons of time and some money too. First, you'll need to have these few things defined before you start shopping around to avoid being overwhelmed with everything that's offered today. One of the first questions you need to answer for yourself is, what kind of time investment are you looking for? The main trade-off is going to be less tinkering time equals less customization and features, while the opposite remains true on a linear scale of time investment versus capability. As an engineer, I personally love tinkering and dealing with technology and hardware, but when it comes to 3D printers, I prefer something more turnkey and user-friendly, like a TD or a Bamboo printer. With that said, you lose some of the customization and advanced features when building your own equipment with more capabilities and specialties that you can get with something like a Voron or Creality brand printer. Then there's kind of the middle tier that still needs some time investment but offers some good features and customizations, something like a Prusa or a Soval printer in my experience. Next, you should consider how you plan on using your 3D printer. Are you just doing it to make some fun small models and figures, or are you ultimately looking at turning it into a side business with mass production? If you plan on turning 3D printing into some kind of side business, I would highly suggest opting for more turnkey and reliable equipment. Additionally, considering the size or volume of the models you're looking to print, which will determine the size or build volume of your printer. Finally, considering the environment where you will have your 3D printer. If you plan on keeping this in a garage or an area that can get cold during the winter, you really should consider opting for an enclosed 3D printer, since cold drafts and temperature changes can cause tons of headaches while you're trying to print with an open printer in a cold environment, causing some parts of your print's filament to cool too quickly. After you answer and decide on all these parameters, now you have a great baseline on what you should be looking for and can start to shop for printers within your price range. The biggest driver for price will generally be your printing volume, so if you need to cut down on cost, opt for the physically smaller printers, especially if you're unsure of answering some of the questions you see here on the screen and aren't looking to invest too much money when you're first starting out in the hobby. Luckily, that won't limit you too badly on overall print sizes, which we'll actually cover a workaround for that in one of our other tips later in the video. Our next tip is to decide how much prep work and post-processing you want to do for your prints. This is going to decide what filament materials and extra accessories you're going to need for your printer. First off, concerning materials. Depending on what you plan on printing, something like figures will require a bit of post-processing to get the desired finish and look, such as sanding, priming, sanding, priming, more sanding. I think you get the picture. There's a lot of surface prep involved when you opt for PLA and want a nice smooth finish. If you aren't too keen on spending a ton of time on post-processing your models, ABS may be the way to go in terms of filament selection, since you can use a process referred to as an acetone vapor bath in order to smooth out any imperfections and obtain that nice clean finish that you're looking for. But some people aren't bothered by the small lines of their prints without any surface prep, so if you want no labor in model prep whatsoever, you can kind of just leave your print as is too if that's your preference. The final post-processing aspect to consider is painting. If you don't want to do any model painting whatsoever, some model of multicolor filament changer may be your best option. This does create a bit more of waste of your material, but it is a huge time saver in the end for finishing work on any of your more colorful print jobs. Tip number 3 covers optimizing the most critical slicer software settings. Since there can be upwards of hundreds of different parameters you can mess with in your slicing software, we're going to cover the most critical settings that affect your prints the most and the ones that I often see overlooked in beginner forums or discussion threads. First setting is going to be our infill. This will be one of the most important settings to determine the strength of your prints. Generally, for any decorative or non-structural prints, a 10% infill is more than good enough and saves you a ton of filament and weight on your print. In terms of pattern, I always prefer to use gyroids since it is one of the most stable and highest strength to weight ratio in terms of geometric stability. Now, for anything that will be sustaining any weight or used as a structure, 30% infill will kind of be your absolute minimum. Some stuff like my axle barbell holder, I printed at an 80% infill so it can hold 80 pounds without any issue. The other critical setting that will determine the overall strength of your models will be your wall count. Funny enough, the default values on this vary pretty greatly across slicing software, so you may run into problems if you don't pay attention to changing the setting. Sovol Slicer actually defaults to 5 walls, which is way overkill for any decorative or non-structural print. And on the flip side, Orca Slicer actually defaults to 2 walls, which I think is way too thin for any print that's not just a big cube or a chunk of plastic. Anything decorative or non-structural, try to stick with 3 walls like you see here for our Detroit Sports rotating display or this alien face hugger. Using the barbell holder as an example again, we use 5 walls since we needed that added structural reinforcement to sustain higher loads. Generally, anything under 3, you really risk having a fragile build for smaller cross sections, and anything over 5 is generally overkill and a waste of any kind of material and printing time, just in my experience. Another important setting is to understand supports and proper orientation of your model in order to limit supports when possible. Now, how the slicing program works for 3D printing is taking horizontal slices parallel to your build plate, so that if you have any floating portions of your model, like you see here with our snap-on cup holder, it will have nothing to print on unless you provide some kind of support right here at the base. Otherwise, it's just going to float, nothing to print on. Just an extra little tip as well, a general rule of thumb is any slope shallower than 45 degrees should use a support to prevent any odd warping, blemishes, or stray filament on your print. So, like you see here in one of the jigs that we actually built up for our production, as long as you keep a 45-degree angle or less, you have no problem printing. This needed no supports and it came out perfectly fine. So when you start designing your own models and things like that, really keep that 45-degree limit in mind to prevent using unnecessary supports during your prints. There are 2 types of support styles, tree or standard. I essentially always default to tree support since they are so much easier to remove and use up much less filament for the same level of support. Also, keep in mind that different slicing programs generate tree support geometries much differently. Something like Sovol Slicer creates almost a wall of tree supports, while something like Orca Slicer or Bamboo Studio generate really clean tree supports that branch out to the necessary areas accordingly and efficiently. I'm going to save you a bunch of time and frustration. Please screenshot these settings so you always have them. These are the most optimal support settings for 90 to 95% of the prints you're ever going to do. This will provide the proper support that your model needs while being so easy to remove and reducing the risk of damaging your print. Settings far outside of this baseline will either fuse too much with your print and leave these marks or even break thinner portions of your print, or it will take a ridiculous amount of time to remove these, or will be placed too far below your print overhangs, leading to all this weird stringing and incomplete prints in some areas. So please learn from my mistakes, use these settings as your default baseline for your supports on 3D prints with tree supports, and your life will be much easier than mine was when I was first starting out and struggling through finding the optimal support settings. Tip number 4 is to start learning some general CAD skills. This is going to make your 3D printing life so much easier and will just open up a huge amount of possibilities and flexibility to what you're able to print. I would suggest using FreeCAD. Like its name suggests, it is free and has just about any function or feature you will ever need from a CAD software. It does have a pretty steep learning curve if you don't have any experience with other computer-aided design software, but there are plenty of resources out there in forums, YouTube, to help you navigate all the features and functions that it offers. Now, if this software is just too complex for you starting out, Opt for some of the other basic platforms to start to build your confidence with the entry-level functions. But going back to the beginning of this video when I said opting for a smaller printer is not necessarily a huge issue, this is the reason why. While there are other softwares out there that will auto-slice any kind of models into multiple pieces to print on a smaller printer, then you assemble the pieces during post-processing, they sometimes don't really optimize the best planes to cut in order to minimize supports or even avoiding the need for adaptive layers on rounded surfaces with the certain orientations that it creates. When you're comfortable with a capable CAD software, you can take STL or step files and slice them up however you'd like. Additionally, using CAD software, you can easily resize and scale any mesh file to any size. A lot of slicing softwares offer this feature as well, but it's a lot more flexible and you can customize it easier within a CAD software. One of the biggest benefits is having the ability to modify existing models that you find online. Small things like adding in wall mounting holes in the exact location and the exact size you need, or modifying and even combining multiple files to accommodate complex installation areas. Being able to alter an existing model makes a huge difference in flexibility and how you can combine and modify existing models for essentially any application you want. On top of that, you'll also gain the ability to easily make your own tools and models that don't already exist anywhere else online. I've got some examples popping up on the screen here for applications where I needed a custom part or product, so I was able to just design and print them myself. And once you start generating your own models, there are actually tons of sites where you can sell these CAD files online or even start printing and selling your own products and create an enjoyable and fairly low maintenance and profitable side business. Our fifth and final tip is going to be understanding the importance of prep work and maintenance. You can save yourself so much frustration and avoid so many headaches with super simple and quick prep work tasks to ensure your first layer lays down properly, which is one of the most important steps in 3D printing. Things such as cleaning your build plate after each use. Personally, I just use acetone and a shop towel just to make it easy, or even something like using a common glue stick to ensure that you get good adhesion on your first layer makes such a huge difference. Anytime I've been kind of pulling out my hair for any odd first layer adhesion issues, a basic glue stick or build plate cleaning has fixed my problems 99% of the time. Additionally, routine maintenance on your machine can also prevent some real headaches down the road and limit the failure of larger and more expensive components of your printer. The biggest being lubrication of moving parts. I'd suggest this grease for generally any screw drive, and for any metal on metal moving parts, I like to use this lubricant. Be careful though, you need to pay attention and look up specific maintenance intervals for your machine, such as the Bamboo P1S, which actually has carbon fiber X-axis rods. So you don't want to be using an oil-based lubricant, which will cause major issues with the movement resistance of your print head. Instead, you want to clean the tubes regularly with acetone and a microfiber cloth. Also, have plenty of spare nozzles and hot-end silicone socks on hand and ready. The worst feeling is to have a print pause for multiple days waiting for these basic parts to come in, because you will need to swap them out eventually, and they're super cheap to buy, so just make sure you have a habit of having plenty of spare inventory on hand for these small and cheap parts. I'm actually going to throw in a bonus tip number 6 that is going to save you a ton of headaches also. Invest in a UPS or an uninterruptible power supply, which is essentially just a 120 volt backup battery. Some are pretty affordable on Amazon and will save you a ton of frustration down the road. Depending on what printer you decide on and its maximum speed capabilities, some prints can be upwards of 3 to 4 days of print time, and the worst thing is finding out there was some kind of power outage or a breaker tripped from a circuit overload at like 90% of your print progress. You're going to lose it. So save yourself some heartache and invest in a UPS to make sure you've got the proper backup for any electricity outages that you may have during prints. Plus, it's just kind of handy to have some kind of backup 120 volt AC power supply in your home for any emergencies that may pop up. Well, those are my top 5 plus 1 bonus 3D printing tips for beginners. Let me know if you think there are any critical tips that you think I missed down in the comments below. I hope the info in this video helps save you some time, frustration, and headaches that I had to deal with myself. and wish I had this information before I got started out in the hobby. So thanks for watching, and we'll see you next time. Peace out.